Hello everyone, good evening. I am Mary Joy Defensor and I'm going to report to you the measures of variability. But what is variability? Well, variability describes the spread or dispersion of a set of data. Well, actually, there are several techniques in measuring variability, but in this report, I'm going to focus on range, sample variance, and sample standard deviation. Okay, so let's start with range. Well, with range, we are going to get the difference of the highest and the lowest number given. So, based on the problem given to us in the case, the highest value is 341.1 ml. We're going to deduct the lowest value, which is 339.2. Thus, it gives us an answer of 1.9. So, this is the difference. So, now we know that the range is 1.9. So, this time, we're going to compute for the variance and standard deviation. So, I have the formula here. So, as you can see, we're going to compute for the sample variance and the sample standard deviation. Why? Because the number given to us is actually just a sample and not the total population. So, we need to consider that. So, for the sample variance, the formula is S squared is equivalent to the summation of xi minus the mean squared over n minus 1. So, as you can see, n stands for the sample. But why do we need to deduct -1? Well, this is what we call the unbiased sample. I think there will be, or there's going to be a different discussion for that. Okay, so while the sample standard deviation is just the square root of the variance. So that's easy, that's how easy it is to compute. So, but of course, before we get the sample variance and the sample standard deviation, kindly please check your handouts given to you by my teammates. So as you can see, there's a table there that's like this. It has the first column of xi, which refers to the data yields. Ito yung information given by the case. The second column refers to the data yield deducted by the mean. This is what we call the deviation of the mean. And the third column is the squared of the deviation of the mean. So the third column, the total of the third column is what we need to compute for the sample variance. So, as you can see in that table, the total or the summation of the square deviation of the mean is 8.59. So, to compute for the variance, we have 8.59 divided by the sample population of 50 minus 1, which is 49. So, we have 0.18 as the sample variance. The sample standard deviation, as discussed, is just the square root of the sample variance. So, we have 0.42. Given those values, I therefore conclude that 95% should fall between 339.16 ml and 340.84 ml. And approximately 68% of the data values are within 339.58 and 340.42 ml. Thus, 32% should be outside this interval. So, using the standard deviation, we now know which of the cans contain the normal or the standard capacity. So now, let's discuss the measure of shape. So, for the measure of shape, I've used the coefficient of skewness, which has this formula. So, Sk is equivalent to 3 times mean minus median divided by the sample standard deviation. So, with that, we have 3 times the mean, 340.12, minus 340.15, the median, divided by 0.42. So, we have a result of negative 0.51 coefficient of skewness. So, the shape will be like this. Since it is negatively skewed, so, pag ganito yung shape niya, nandun yung bell shape niya sa bandang right side. So, that's it. Hope you learned something from me. Discussion number 2 will be discussed by April and Mavi. Hope you all have a great night. Bye!